Today we're going to just do a brief screencast on plotting quadratic curves. We've plotted linear curves before. Here's a linear equation, y equals 2x minus 1. We know it's linear because it's only got one x in it, whereas the quadratic has x squared in it. When we plotted a linear straight line graph, we only needed 3 points to get our straight line. So we choose 3 x values. Here we've chosen minus 1, 0 and 1. And then we plug them into the equation and find out what our y values are. So 2 times minus 1 is minus 2. Take away another 1 is minus 3. So x is minus 1, y is minus 3. If we put x is 0 in, well, 2 nothings are nothing, and minus 1 gives us the minus 1. And when x is 1, 2 ones are 2. Take away 1 is 1. So we've got our 3 coordinates, minus 1, minus 3, 0, minus 1, and 1, 1. And when we plot these, minus 1, minus 3, 0, minus 1, and 1, 1, and draw a straight line, we get our straight line graph. All good. To plot a quadratic equation, we can't just use 3 points. We need to plot a lot of points, and when you're given something to plot, like y equals x squared minus 2x minus 2, it will tell you which x values it wants you to plot it between. Here it's minus 3 and 5. And the best thing to do is to create a little table from x equals minus 3, using all the integer values, all the whole numbers between minus 3 and 5, to get a big set of points that we can then plot, and we can see how the curve is going to look. So the first thing we do, x is minus 3. We have to put that into this equation here. So we get minus 3 squared. Well, minus 3 squared is minus 3 times minus 3. A minus times a minus is a plus. So we get minus 3 squared is 9. Minus 2 times minus 3 gives us plus 6. So we have 9 plus 6, which is 15. Then we have to subtract 2. And 15 subtract 2 is 13. That gives us our first y value. Now we do the same thing, but this time x is minus 2. Minus 2 squared is going to be plus 4. Minus 2 times minus 2 is going to be plus 4. 4 plus 4 is 8. Subtract 2 gives us 6. So that's our second value. Similarly, x is minus 1. Minus 1 squared is 1. Minus 2 times minus 1 is 2. 1 plus 2 is 3, and we subtract 2, gives us back 1. Then we get x is 0. 0 squared is nothing. 2 lots of 0 is nothing, so we've got nothing here, and we've got minus 2. And I'll fill the rest in, and you should be able to see a pattern forming here. 13, 6, 1, minus 2, minus 3, and then it increases minus 2 again, 1 again, 6 again, and 13 again. This is the type of pattern that you're trying to look for. It's coming down, the y values, and then they're going back up again. Hopefully it's symmetrical. So now we've got all our points, the coordinates, minus 3, 13, minus 2, 6, minus 1, 1, etc. We can go ahead and plot our curve. Here it is. Minus 3, 13, minus 2, 6, minus 1, 1, 0, minus 2, 1, minus 3, 2, minus 2, 3, 1, 4, 6, and 5, 13. And then once you've plotted your points, you draw as smooth as possible curve through those points. You can see that it's symmetrical about the line here, x equals 1. And its lowest point is at y equals minus 3. Now we've plotted our curve, sometimes they get you to solve equations using it, and that's what we're going to look at next. So here's our equation, y equals x squared minus 2x minus 2. Here's our graph of it, and they've asked us to solve x squared minus 2x minus 2 equals 0. Well, if you compare this with this, you can see that basically the y is 0. So we're going to replace our y with 0 to solve x squared minus 2x minus 2 equals 0. And what I've done here in green is I've drawn the line y equals 0 on here. It's just the x-axis. If you remember, lines horizontally are y equals something and lines vertically are x equals something. So now, how do we solve this? Well, we've got the line y equals 0 and this curve y equals x squared minus 2x minus 2. What we want to do is find out where they're equal. And if you think about it, they're equal where these two lines intersect. So all we need to do is find this point here and this point here. So I've put some little crosses here, and it's always an estimating game when we're plotting graphs. So it looks like it's about at minus 0.7, and it looks like it's about at x equals 2.7. So you just write your answer down. X equals minus 0.7 and x equals 2.7. If it was a slightly different equation, let's say solve x squared minus 2x minus 2 equals 3, then we need to plot a line here, y equals 3, so that we can find out where the solutions lie. This is what I've done here. Here's the line y equals 3. We know how solving this solution is going to be when the two lines cross, which is here and here. But how do we find our x values? Well, what we have to do is drop down to the x-axis and find out what those values are. So here we've got about minus 1.5 and here about 3.5. So our answer here, x squared minus 2x minus 2 equals 3, is solved when x is minus 1.5 and x is 3.5. Again, these are just estimated solutions. They may not be accurate enough to give this equal to 3, but it's a good guess using a graph plotting technique. Now we've plotted graphs and solved them for some equations, I'll just go over some of the key points and key parts of a quadratic graph. So here's a quadratic graph, a greater than 0, so we've got a nice smiley face. I just want to go through the significant points that are associated with a curve like this. Where it crosses the x-axis, we call those the roots of the equation. That's when this curve equals 0, as in the previous slides. We call where it crosses the y-axis, again, the intercept, just like we do on a straight line graph. And we call the minimum point, or if the curve is in this direction, a maximum point, we call it the turning point. It's where this curve is going from coming down to going back up again. It's called a turning point. You just need to know those. They may ask you what the coordinates of the turning point are, and you just read the coordinate off. If you look back at our previous example, it was at 1 minus 3. Just double check that if you're not sure. So that's plotting quadratic graphs and some of the important information associated with them.